All right, y'all. So 6.8, like I said, deals with increasing, decreasing. And piecewise functions.
I do the value.
All right,
Okay.
so they start out with the piecewise functions, sort of describing what they are. And then we'll get into the increasing and decreasing. So a piecewise function. So, y'all, this is a function with a set of equations that depend on the x value to determine which equation we use to evaluate the function. Okay, so they'll give me 2, 3 equations or so, and they'll give me domains for these equations. And depending on my x value, I figure out which domain it fits in, and then that determines which equation I'll use. So, y'all, I'm going to do something we all know about, and that's our paychecks. And I'm going to show you a piecewise function using a paycheck, okay? So say P is going to represent my paycheck, and T is going to represent the number of hours. So my little, and I'm just going to use 2 equations for this one. So my first equation, say you made $20 an hour. If you make $20 an hour, to figure out your pay, you would do 20 times T, which is the number of hours you work. And that would be good for any T that is less than or equal to 40 hours. Now, at this job, if I work over 40 hours, I get overtime. So to figure out my overtime pay, it would be 800. And 800 would be the amount of money you would get at $20 an hour times 40 hours. That would give you 800. Plus your overtime would be time and a half, which is $30 an hour, times T minus 40. So your total number of hours minus 40 will be your overtime pay at $30 an hour, plus your 40 hours at 20 would give you that 800. I would use this equation for any T that was greater than 40. So a question I might ask on this, which equation would I use for 35 hours? Now, I don't care about the value. I just want to know which of these 2 equations would I use if I work 35 hours? Well, this first equation is telling me, hey, if your hours is less than or equal to 40, we're going to use the first equation. Anything over 40, I would use the second equation. So if I just work 35 hours, then I would use the equation 20 times T. And then I would plug in my 35 for the T, multiply and get that answer, okay? Now, later on, we'll evaluate these, but for right now, they just wanted us to pick which equations we would use. This is to see that you're getting the idea of this, okay? So, y'all, which equation would I use for what if I work 45 hours? So if I work 45 hours, I'm going to come up here and look for which t I represent. Well, 45 is not less than or equal to 40. So I'm going to look at the second equation. It tells me for any time greater than 40, I would use the second equation. So if I work 45 hours, the equation to figure out my pay would be 800 plus 30 times my t minus 40. So see if I put my 45 in here, 45 minus 40 would give me 5 hours of overtime at $30 an hour, plus my 40 hours that I did at $20 an hour. All right, so one more on these, and then we'll play with some of their examples. So which equation would I use for 40 hours? And this is where I get people at sometimes, but remember, this has t less than or equal to 40. So if my t is 40, then I'm actually going to use that first equation again and figure out my time by doing 20 times t. So y'all have done this if you've worked jobs that are paying by the hour in your life, okay? So let me show you some of their examples that they're going to hit you with. So we're going to turn the page, y'all. So for their number one, they're giving us f of x. And y'all, they got 3 equations. They got x minus 2 for any x that's less than -3. It's going to equal x squared for -3 less than or equal to my x less than 2. So that means if it equals -3 all the way up to less than 2, I'm going to use the x squared equation. And then I'll use the 8x equation for any x's that are greater than or equal to a +2. So the question is, which equation would we use to find f of a -9?
It's,
Oh, I think I heard it. What did you just say?
and it's x minus 2.
Yeah, the very first one, right? Because that -9 is less than -3.
Mhm.
So we're going to use the x minus 2. All right, y'all, let's try this one. So this one has 3 equations also. It's going to equal 3x for any x less than a -5. It's going to equal x squared for -5 less than or equal to my x less than 4. And then it's going to equal x minus 4 for any x's greater than or equal to that 4. So they want to know which equation would we use to find f of 10.
X minus 4.
Is it 3x? The first one?
Okay, so I'm finding f of 10. So you're looking over here.
X minus 4.
So x minus 4, because if you look at that 10, 10 is greater than or equal to a 4. So since 10 is greater than 4, we're going to use this equation, which is the x minus 4. And y'all might have had that first on the, whoever said that first, but I was getting sort of staticky on my end, so I'm not sure what y'all were saying. All right, so one more of these, and then we'll play with those increasing. So y'all, this one has f of x, and I got 3 equations again. X minus 4 for x less than -4. It's going to equal x squared for -4 less than or equal to the x less than 1. And then it's going to equal 5x for any x that is greater than or equal to 1. All right, so what they want to know, which equation would we use to find f of -4?
Is it the second one?
Second one, because see, this one says it has to be less than -4. But y'all right here, it says -4 less than or equal to my x. So since -4 is equal to -4, we're going to use that second equation, y'all. Good job. And I would plug it into the x squared equation. All right, so if y'all remember yesterday at the end of class, we sort of played with those support problems dealing with increasing and decreasing. So for the next few problems, I'm going to go into the math lab and we're going to look at those graphs and figure out what those intervals should be. So I'm going to switch my page to the math lab real quick. All right, y'all, let me move my. All right, y'all, let me see. I'll make that a little bigger for us. So we're looking at a graph here. Now, they want to know what increasing interval this has. Now, remember, read the graph left to right. From left to right, if it's going downhill, it's decreasing. If it forms a horizontal line, it's constant. And if it goes uphill, left to right, it's increasing. Now, when I look at increasing intervals, I'm only concerned with the x values. So y'all look on this graph, the third part on the right is going uphill. So what we want to know is, at what x value does it start going uphill, and then where does it go? So y'all, let me see. So I'm looking at the right side where it's going uphill to the right. The x value where that starts going uphill, if we go straight down, that looks like a 3. And then y'all, as this graph heads to the right, what x values do we say we're headed towards?
Infinity.
Infinity. Now remember, on increasing, decreasing, and constant intervals, they always use parentheses. They never use the brackets on these unless it's got a stopping point, okay? But since these arrows go on forever, this goes from 3 to infinity in parentheses. So we would actually choose D on that one. So y'all with me on that? All righty. Next, they're going to ask us for what intervals is it constant? So what intervals does this look like a horizontal line? So we want to start on the left side of it and go to the right side of it. So y'all, would y'all pick A, B, C, or D?
D.
Oh, I couldn't hear that. Which one was it?
D.
As in boy?
D is in dog.
Okay, that's what I'm thinking. D is in dog. There you go. Because it starts at -3 on the x-axis and it's going straight across until we hit +3. So good job. I'm gonna have to start using my military lingo with y'all. Alpha, Bravo, Charlie, Delta, right? So what would y'all say is decreasing? Because it's coming in from the left side, way out there somewhere on the left side, and it's decreasing until it hits, looks like that x value of -3. So y'all, what's that left side coming in from?
Negative infinity.
So you're going to pick A, B, C, or D?
C.
As in Charlie?
Yes.
Okay. And there you go. So that's your trick on these. Focus on the x's. Do not focus at y values at all when you're looking at these intervals, okay? We don't care how much it increased. We just want to know the intervals where it was increasing. So y'all, then they start throwing some tricky ones at us. This sort of looks like the one we did yesterday in support. So notice, increasing, there's two places where this is increasing from the left to the right. The second line going uphill, and then the fourth line's going uphill. So what we want are the x values of that first line going uphill. So let's see the bottom of the line. If you look at the dot and go straight up, oh, what is that? -1, 2, 3. Looks like -4 there, right?
Yes.
And then if we look at where it ends at over here and go straight down, that looks like it's ending at -2.
So it's D.
So it's got to be D, right? Because that's the only one. But now there's another piece, so I'm going to pick D.
Which line are you looking at?
Yeah,
For the
which one are you looking at?
Say again.
Which one's the first line, second line?
Okay, so let me try to draw something like this and do this on paper real quick. Okay, so y'all let me just
So I'm trying to see which line on the graph, which one are you looking at first? The
Does
straight
my-
line at the bottom, or
let me ask y'all, can y'all see my pointer moving?
yes, now I can see it.
Okay, so I'm looking at this first line, well, which is the second line actually, but it's the first one going uphill.
Okay.
And I'm looking at this bottom dot on it first. And on that
Okay.
bottom dot, I wanted to go up to the x-axis and see what that value was.
Okay.
So we said that was -4 there, right?
yeah.
Now I'm looking at the ending of that line up here by the 10 almost. And I'm going to come straight down to that x-axis.
Oh, okay.
And that looks like -2. So that first little part of it went from -4 to -2. Now we're going to go over here and look at this last line, because that is also going uphill left to right. So I'm going to look at the start of it down here at the V, and I'm going to go up and see what that looks like. That is on that x-axis. So let's see if I count over, that looks like what? 1, 2, 3. So it looks like it's starting at 5 on the x-axis with the second line, and then come up here to see where it ends. And then I'm going to go straight down on the x-axis and see what that value is. And y'all, what's that? That's 1, 2, 3, 4, 5. Looks like 8 on the x-axis. So the two lines, the first one went from -4 to -2. The second one went from 5 to 8. So just focus on the x-axis only, okay? So which one would we pick? We would pick D on that one, right? All right, y'all. So let me let y'all hook this one up. So where is it decreasing? So y'all, the third line right here is decreasing, the one you see my cursor over. Where does it start decreasing and where does it end decreasing? So let's find that first point. We're going to go straight down. And that's what, negative?
-1
-1. So let me put in that -1.
and
It is-
+5.
And it's going to be +5 because see, that one ends where that other one picked up. All right, so from -1 to 5, that line went downhill. So next, they're probably going to want that little straight line on the bottom.
Okay, how did you get -1 and 5? Which one did you start with?
I'm looking at the third line where my cursor is. Do you see my cursor?
Yeah.
Okay, so that's the left side of that third line. That's the one that's going downhill.
Mhm.
So I'm going to take it straight down to the x-axis and see what that point would be. So I'm one left of the y-axis, so that's where I got my -1. Now follow my cursor to the end of that line. That's where it stops going downhill. I'm going to go straight up and see what that x value is. And at that point, I'm getting that 5. So whoever just asked me that, here we go. We're going to do this straight line down here. That's constant. Constant means the y values stay the same as it goes left to right. So I'm on the dark side, the dark dot on the left side. If you go straight up on that x-axis up here, what's that value?
Five.
Oh, what are y'all saying?
-9.
-9. Because see, y'all remember, I'm going straight up to the x, which gave me -9. So look at the end over here, that's hollow. That hollow point, if you go straight up to the x-axis, what's that value?
-4.
-4. So y'all, we would put in our -4. So that one went from -9 to -4. Remember, you got to read them left to right on these, okay? And then you're going to check that answer. Don't worry, I got plenty of these. All right, so this one's what, number 6? Increasing is going uphill left to right. So if y'all can see my cursor here, the left side of that hump is going uphill. Then it goes downhill. Then it's constant. Then it goes uphill. And then finally it's constant. So I'm looking for the increasing. There's 2 parts, this left side of the hump, and then this little line in the middle going uphill. I'm going to start with the one on the left. I'm going to put that first one in parentheses. So y'all, this left, if you see my cursor here, I'm looking at this left side of the hump. So these x values are coming in from -infinity, since that's got that arrow. So you would do -infinity. Now, where does the first line stop going uphill? Well, I'm going to follow it to the top.
-6.
And it's going to be -6. Good job. Then we close those parentheses and we do a comma and open up the next parentheses. So y'all, I'm looking at this line right here where my cursor is going uphill. So I'm going to start with the bottom of that. Right down here where it's almost by that 2. But I want to know what x value is that point where it starts going uphill.
-1.
So that's going to be -1. So we would put in our -1. And then notice the line goes uphill.
To 6.
It's 6 on the y-axis.
Oh,
So what is that on the x-axis?
0.
0. There you go. So that was from what y'all say, -1. Oh, my cursor wasn't up there, so let me get it back up there. So y'all said what? -1 to 0 on that one. Close the parentheses. So to make you check that answer,
I think I'm kind of confused now. -0. I mean 0. I'm trying to see.
okay, so you
Oh,
see,
okay. I see where
it's 6
where
on the
it
y-axis, but if you come straight down, you're
Where
right
the-
at the center of that graph,
Ye-
which is the zeros.
Okay, I see it. I see it. Okay.
So decreasing is downhill, and y'all, this right side of the hump is the only part going downhill. The right part of that hump on the left side where my cursor is. So what I want to know, it starts going downhill at the top of that hump. What's that x value?
-6. No, -4.
Oh, you was right. -6 is
Negative
perfect. -6 is perfect. Now, where does it stop at? I think that's what you got me next. So it stops down here at the bottom where that line starts going straight. So at that point, what is this x value?
negative. Well, 0.
-4.
-4.
Yeah.
So you was right the first time on that one. So notice on the x-axis, if I go from this -6 to this -4, my graph is going downhill. Now, they're going to ask us for the constant. There's 2 lines that are going straight across. You got this first one over here, and then the last one on the very top going straight across. So let's start with this first one here. What I want to know is, right here where I got my cursor, at what x value does that start going straight across?
-4.
All right, and it's going straight across until it gets to this point right here, which has an x value of,
-2.
Yeah. -2.
Or yeah.
okay, so I heard 2 different things. What are y'all saying on that?
-2.
Well,
-1.
yeah, -1, because see, -2 is the y value.
Oh, okay. I see.
So go straight up and make that a -1. Now that's the first one, so we're going to comma and put the second one. So the second line on the very top going straight across. Or my cursor is, what is that x value?
0.
0, because remember, get off them y's. So what I would do is come straight down, and I'm at the center of the graph, which means that's the x value of 0. But y'all, this line keeps going to the right and keeps going to the right. So which
Infinity.
our x's are headed towards?
Infinity.
Infinity. So we would put that in and close our parentheses. So y'all, the trick on this, only focus on the x-axis, okay? Do not focus on those y values. Remember, we didn't care how much it went up or how much it goes down. We just want to know the x values where that's happening, okay? All righty, so let me break out a few definitions and then we'll come in and do some more of these. So let me go to my pad. So in this section, they also tell us about what we call a relative max. So they call these relative maxima. So a relative maximum is like a maximum value, but it happens in little sections. So a relative maximum happens when there's a hump in the graph. So these create, what do we call them? We'll just say these create humps in the graph. So we're looking at humps, okay? There's a relative minimum. And a relative minima is a valley in the graph. So these create valleys in the graph. So we're looking for our valleys. Now, there are graphs that come up, have a max, and then they might come down and have a minimum. So what they're talking about, a relative maxima, would be this point. Because it's the maximum point on this little hump. And then down here, like in this valley, this would be a relative minima. Because for this little area, it's the minimum value. So some graphs have a maximum value relative to a hump and a minimum value relative to a hump. Okay, so that's what we're talking about. Almost like finding maximum and minimums. But remember, some graphs have more than one, okay? So let's play with these and I'll sort of show you how they're going to look for you on your homework. We're going to go back here. We're on what? Next question. All right, so let me make this larger. So y'all, the first question, this graph only has one, but does this graph have a relative maximum or a relative minimum?
The first one.
Yeah, it would have a, so it's got a relative maximum. Good job. So watch this, you're going to hit enter. So now look at what they're asking. They're saying the relative maximum occurs at x equals what and has a value of what. So we want to know, first of all, the x value of that maximum. And they're giving us that point right there. So the x value would be what? Negative, what is that? Is that a 6 point? Is that 6.5?
Yes.
Okay. And it has a value of what? So now you want the y value because the y value gives you the values of the graph. And the y value, I can't tell what that is. It looks like a 4 point something.
4.25.
4.25. There we go. So y'all, you would punch that in. So now let me ask y'all this. Knowing what we know about increasing and decreasing, what interval is this graph increasing? Where is it going uphill from? So it's coming in from the left side from somewhere, and it's increasing until you get to that point right there.
Negative infinity,
negative
negative 6.5.
Oh, that's cool. So that would be, it looks like what, C on that one. There you go, y'all, good job. Now, if they're giving us the maximum point, then it's going to increase till it gets to that x value, so good job. So you would check that, and I bet it wants to know where is it going downhill. So y'all, if it's increasing from negative infinity to negative 6.5, where is it decreasing from?
$4.25 to negative infinity.
The regular infinity.
Negative 6.5 to positive infinity.
Yeah, because see, if y'all notice the top of that point, remember, still has the x value of negative 6.5. So 6.5 is the changing point from where it went uphill to where it's going to start going downhill. So we would go from that negative 6.5. And remember, as my x's go to the right, that graph is just going down and down and down. So that would be towards positive infinity, y'all said. So y'all, looks like y'all are going with D on that one. Y'all, we got more. We're going to get y'all fixed. Let me try the next one here.
That one kind of confused me because how isn't it a negative infinity?
On the first one?
Yeah.
Oh, hell, it gave me another problem. So we're going to do it again. Here we go. But it's close. So you see, we're looking at the part going, it wants to know if we got a maximum or minimum. So what are y'all saying on that?
Maximum.
So it's going to be a relative maximum. Now, the maximum occurs at what x value? That'd be what? Negative 5.5 is the x value. And it has a value of 4.25, because remember, the values are always those y values. So you would put that in there. Now, here's the question we had a while ago. On what interval is it increasing? So remember, you're reading these left to right. So it's going uphill. So this little part where my cursor is, that part's going uphill left to right. So now, remember, this thing goes on forever and ever with that arrow going down. So we're saying we're coming in from the left side of this graph. If we're coming in from the left side of a graph, we're coming in from what?
Infinity? Oh, negative infinity?
So negative infinity. So watch this. You're cruising along the x-axis. You're coming in from negative infinity, and you're cruising and cruising and cruising until you get to right here. At this point, that graph stops going uphill. So that x value is going to be the same as the x value that you got on that maximum while ago. Because that's the point where it stops going uphill and it starts going downhill. So that would be what? Negative 5.5. So on that one, we had to choose, let's see, we said C, there you go. And then we check that. And decreasing is going to start on the x-axis where that one ended. And that'd be what? Negative 5.5. And as this graph heads right out the x-axis, the graph is going down and down. And I think you said C, didn't you?
Yes.
Yeah, that's it. So from that, so you just got to focus on the x value they're giving you for that point. So when you got a parabola, the vertex, which is sort of what this is, right? The vertex point, that x value is the ending for one interval and the beginning on the next interval. Now, this next question, let me make this a little larger. All right, now I'm going to pull it down just a little bit so we can see that. All righty. Notice this one has a relative maximum where the little hump is on the left side. And we're seeing that -6, -1. That's a little maximum for that hump. But then look, we got a little valley down here. And they're telling me the little valley's point is 2, -33. So let's start over here. Now notice, they're in a different order than they did while ago. While ago, they wanted the x first and then the value. Well, this one says, hey, the relative maximum is what value, and that happens at what x value. So y'all, for the hump, the relative maximum is the -1. Because remember, the min or maxes are always the y value. And then that happens at x equals what?
-6.
-6. All right, they're going to do that with that minimum now. So y'all looking at the second point down in the valley, what is the value of that relative minimum?
-33.
And that happens at an x value equal to
2.
That is a 2. There you go. Whoops. Now, we're going to continue on and see what they say. So what intervals is it increasing? Now notice going left to right, if you follow my cursor, it's going uphill right here. And then at that little valley there, it starts going uphill again. So we got 2 intervals. So let's look at this left side first.
A.
So it's coming in from negative infinity to -6. Good job. And then the second one starts at 2 to positive infinity. Good job. Now, you would check that, and guess what? They're going to want the part where this is decreasing. And y'all notice it's decreasing on this second part right in the middle here. So what x values does it start decreasing to and then stop? A, B, C, or D? And really, I'll tell you a trick. You're just looking at the x value of that hump, which was negative,
-6.
and then the x value of that valley, which is,
A.
so y'all said, yep, A looks like it, because it's going to go from that -6 from that first point down to the 2 on the second point. So let's see, you would put that in, check that answer. All right, y'all, so let me make this a little bigger. Now notice, they're giving us 4 answers over here. So let's play with this a second. This dot that's sitting right on that 1 on that y-axis, that is a hump. So that's going to be a relative maximum. That's the relative maximum of 1, which is the y value at x equals 0. So that point would be 0, 1. So that means it has a maximum of 1 at x equals 0. So let me see which one says anything like that off the bat. Oh, so y'all, I've got 2 choices at the moment. B has a relative maximum of 1 at x equals 0. D has a relative maximum of 1 at x equals 0. So it's going to be one of them 2 answers, B or D. So now we got to figure out what this minimum value is. So this second point down in the valley, what's that y value?
-3 and 2.
And it happens at x equals 2. So let's see. So B said, hey, it didn't even have a relative minimum. So we're scratching B. And the only one we can go with that matches what we just said would be D. So you're just picking one of them 4 answers on that one. And then it's going to the next question. All righty, so I'm going to go back to the pad now. So y'all, that is the trick on those, of just following your X's and not worrying about the different Y values, okay?
Are you going to work 10 and 11 as well?
Oh, I'm about to right now.
Okay.
But they're doing different things. So 10 and 11 go back to doing the piecewise function. But remember a while ago when I did the piecewise function, all we did was figured out which equation we would use. Well, now they want us to actually find the values we would get. So we're going to have to plug our X values into one of them equations and see what we get. So for this one, for the piecewise function, they want me to find the values. G of a -4, G of a +4, and G of a 7. So they want me to find 3 things here using the following piecewise function. which is g of x. And this only has two equations. I got x plus 5 for any x less than or equal to 4. It's going to equal 9 minus x for any x's that are greater than 4. So if it equals 4 or less, I'm using the first equation. If it's any number greater than 4, I'm going to use the second equation. So y'all, my question is to find g of negative 4, first equation or the second?
The
The
first
first one.
The first one. Y'all, because negative 4 is definitely less than a positive 4. So since we're using the first equation, we're going to bring that equation down and put that negative 4 in for that x. So I'm going to have negative 4 plus 5. And let's see what we get. That's basically 5 minus 4, which gives us a 1. So g of negative 4 equals 1. So now we're going to find g of a positive 4. So for g of positive 4, would I use the first equation or the second equation?
The first.
The first one again because of the equals. So that means put a 4 in for that x. So that'll be 4 plus 5. And y'all adding that, we're going to get a 9. So then we had what? G of 7. First or second equation?
Second.
Second, because 7 is now greater than 4. So we use the second equation. That's 9 minus x, which is 7. And that's going to give me what? A positive 2. So these ain't so bad if you can get used to that domain stuff on each of these equations. So let me show you number, that was 10. So now we're going to look at one like number 11. And actually, let's just go play with these on Math Lab, see what they're doing to us. I'm going to go to Math Lab. So they're giving me different numbers on this than I had on my printout. So y'all, negative 4, less than or equal to 2, greater than 2. So would you use the first equation or the second?
I have a question real quick though.
Yeah, I hear you.
Okay, so on the last problem we had, did you use the 9 from the 4 plus 5 to do your last part?
Are you talking about the one I did on paper?
Yeah,
So right here?
right.
Yeah. So I looked at the 7 and I was looking at these two numbers right here, and 7 was greater than 4. So what I did, I had to use this equation,
Oh, okay, now I
9
see.
minus x, and in place of my x, they wanted me to put that 7.
Right, okay, fine,
Okay.
sorry.
All right, no problem. All right, so y'all said what? First equation, because it's less than 2. So that means put a negative 4 in plus that 3. So negative 4 plus 3 is what? A negative 1. All right, y'all, to find g of 2, top equation, bottom equation.
first one.
All righty, so that means put a 2 in for that x, and what do we get?
8.
5.
Okay, 5, because remember that's a 2 plus 3, so that'd be what, 5?
Okay. Yeah.
So check that one. G of 8, top equation, bottom equation.
The bottom.
Okay, so what is? Put 8 in that, we get 5 minus 8.
-3.
Negative 3. And y'all, that's a trick on those, to just figuring out. The biggest mistakes I get on that is people putting those x values into the wrong equation, okay? Now this one, let me write down, they want h of negative 10 h of -3, h of 2, and h of 4. And the equation they're giving me is h of x equals -2x minus 14 if my x is less than -4. It's going to equal 2 for -4 less than or equal to the x less than +2. And then it's going to equal x plus 5 for any x's greater than or equal to 2. So I'm just going to do these on my pad real quick. So the first one they want me to find is h of -10. So y'all, we got to figure out if we want the first equation, second equation, or the third equation.
Is it the first?
It is, because -10 is definitely less than -4. So we will take our first equation, -2 times my x, which is -10 minus 14. All right, y'all, -2 times -10 is a 20 minus 14. So that gives me what, a +6. All right, let's try the h of -3.
Is that the second one? Equation you gonna do?
Yeah, because -3 is in between -4 and +2. But notice,
It only got,
anything that's in between that -4 and that 2 that fits into the second equation, well, there's not even a variable with that one, is there?
no,
So anything that's in that interval automatically equals 2, and that's it. That would be like the straight line going straight across that horizontal line, that constant section. That's what constant means. If you're in this interval, then your y value is always going to be 2 for this section, okay? All right, what was next? H of 2. Which equation? So let's see. Here's the 2's. Now this one says it has to be less than 2. This one says, hey, you
See the
can
last
be,
one.
because you can be greater than or equal to 2. So that we would actually have a variable to plug into. So put our 2 in for the x, and we get 2 plus 5. And that gives me what, a +7. And then finally, y'all, we had an h of 4. First, second, or third equation.
that, the second one, ain't it?
Which one are y'all saying?
The second one,
Well, think about this.
The third.
that's the third one.
Because remember, this one says your x has to be greater than a -4, but still less than that 2. For my third one says, if your x is greater than or equal to 2, we'll use it. So I'm going to use the x plus 5. I'm going to put my 4 in for the x. And then y'all 4 plus 5 gives us our 9. All right, so let me play with that again with y'all. Let me see if I can get a different problem on MATLAB. Oh, so that's the same. So I'm gonna, let me switch page and see if it'll give me another one. All right, so this was different. So if my x is -8, first equation, second equation, or the third equation?
First.
All right, the first one, because -8 is less than -6. So y'all would put a -8 in. -2 times -8 is a +16. 16 minus 17 is going to give us a -1. All right, y'all. So next, they want you to find me h of -2.
The second one.
The second one, because -2 is in between a -6 and a +2. So if it's in the second equation, what's that answer equal?
-2.
2.
Well, yeah, because go with the 2, but it's positive, so make that a +2.
Mm-hmm.
All righty, so you're going to check that. Now they got h of a +2. So which equation?
The third one.
The third one. So put a 2
So
in for that x, and what do we get?
3.
3. Sounds good to me. And then finally, you got to figure out h of 9. Which equation?
The third one.
Uh-huh.
10.
So put a 9 into that. What do we get?
10.
There you go. But y'all, they're not too bad. You just got to play with them and figure out which equation to use. That's the big thing on those, okay?
Yeah.
All righty, y'all. So let me stop my share because I'm going to pause this so we can do our breaks and stuff. Going. And y'all, 5.4 only looks at one little formula here. We're looking at what we call the difference quotient. So this is to get some of y'all ready for business calculus if you ever have to take that class. So the difference quotient, and they give you this formula on every problem, but the difference quotient is f of x plus h minus f of x all over h. And in all reality, y'all, this is just a fancy form of the slope formula when you have functions. So the first thing you do to this problem is we find f of the x plus h. Once I find my f of x plus h, I'm going to plug that into the formula. Okay, so plug f of x plus h and f of x. Then they'll give us f of x. So we'll plug f of x plus h and f of x into the formula. At that point, we combine like terms on the top. Now you'll notice when we combine the like terms on top, all the terms that do not have an h in them will cancel out. So at this point, when I combine like terms, the only terms that'll stay with us are the ones that have the h's in them. And then my last step, simplify the resulting fraction. And what that means basically is remove one factor of h from all terms. Okay, so the stuff I had on top, if it had an h in it, when I divide by this h on the bottom, I'm going to be canceling one h out of every term on that top. Okay, so that's the steps I'm going to do. So let's play with one of these. So this would be like y'all's number 1. It's going to give me a function, f of x equals 6x minus 4. They want us to construct and simplify the difference quotient. And then they tell you the difference quotient once again is f of x plus h minus f of x all over h. So they'll give you that formula every time. So the first thing we said we had to find was the f of x plus h. So f of x plus h. To find f of x plus h, we take the f of x equation and put a x plus h in for that x. So if I do that, that'll give me 6 times x plus h minus 4. So it still looks like f of x, except for that x is now x plus h. So y'all, we need to get rid of the parentheses by distributing that 6 through the parentheses. So that'll give me 6 times x, which is 6x, plus 6 times h is 6h. And then at the end, I bring down my -4. Now we have no more like terms, so that's as far as we can simplify the f of x plus h. So then after I found that, I said, plug the f of x plus h and the f of x into this formula. So I'm going to plug it into the formula. Here's my f of x plus h minus my f of x. All of that will be over the h. All right, here's from f of x plus h. We got 6x plus 6h minus 4. F of x they gave us, that would be 6x minus 4. Now, y'all, here's the fun part. Everything in the second parentheses is going to cancel with its counterpart in the first parentheses. So you got a 6x here. If you subtract 6x, they're going to cancel. So the 6x's cancel. Now look at here. You got a -4 here. Minus a -4 makes that a +4. So this -4 is going to cancel with that -4. So all that's left on top, we said had to have a h on them, right? So here's my 6h, which is left. On bottom, I still have an h. So notice when I combine like terms, all the terms that didn't have a h in them canceled out. Now, we're going to simplify this resulting fraction. Well, y'all, what can I do with them h's? Those h's are going to cancel out. All that's left is our 6. All right, let me see here. I had one coming in. Okay. All right, so the final answer on that would be a +6. So y'all are not too bad. You just got to follow your little formula here, okay? Question on that. All right, y'all, let me do number 2. So number 2, the same thing. They're giving me f of x equals 3x plus 8. So we're going to construct and simplify the difference quotient again, which is f of x plus h minus f of x all over h. So remember, the first thing we got to do is find f of x plus h. That'll equal the f of x equation we're going to put an x plus h in for that x. So we have 3 times x plus h plus 8. So if you notice, these first two problems are very similar. I'm going to get rid of these parentheses by distributing the 3 through the parentheses. So I'm going to get a 3 times x is 3x plus 3 times h is a 3h. And then at the end, bring down to 8. So we now have f of x plus h. We can plug everything into the formula. So f of x plus h was 3x plus 3h plus 8 minus f of x they gave me, which was 3x plus 8. All of that divided by the h. All right, y'all, so look what happens. Everything that don't have an h in it again is going to cancel. So this 3x is going to cancel with this negative 3x. This positive 8 minus positive 8. The 8s are going to cancel. All that's left is a 3h over h. And y'all, guess what? Once again, h's cancel, giving me a final answer of 3. All right, so those first two, not too bad, y'all, but watch what's coming up. This time, they're giving me f of x equals x squared plus 1. All right, we're still plugging into our difference quotient. F of x plus h minus f of x all over that h. So if you like doing a little algebra, this is going to be more fun for you. So let's find f of x plus h. So replace that x with x plus h. You're going to have a x plus h squared plus 1. So guess what? We're going to do some side work. And we're going to figure out what x plus h squared equals. Now, y'all, whatever we get here will be the same thing y'all can use for this. Anytime we get an x squared and we plug in the x plus h for it, we're always going to get the same answer I get right here. So what I'm going to do is FOIL this, x plus h times x plus h. So multiplying, we get x times x is an x squared. X times h is a hx. I'm just keeping mine in alphabetical order. This h times x is a hx. And then the h times the h is a h squared. So now come in and add your like terms. So you're going to get a x squared plus 2hx plus h squared. Y'all save this stuff right here, because anytime you get this x plus h squared, we're going to replace it with that. So that means this equals x squared plus 2hx plus h squared, and then at the end, bring down that positive 1. So the first question, we do not have any like terms here, so we cannot simplify this any further. So since I can't simplify it any further, I'm now going to plug it into our formula. So f of x plus h was x squared plus 2hx plus the h squared plus 1 minus my f of x, which was the x squared plus 1. We're going to divide all that by the h. So that's the whole trick to this formula, is finding this f of x plus h stuff. Because once we find that and plug it in, it's just now simplifying all this. Remember, if it doesn't have an h like these two do, it's going to cancel. This x squared cancels with this negative x squared. This positive 1 cancels with this negative 1. And y'all notice every single time the second parentheses cancels away, okay? So let's see what's left. 2hx plus h squared all over h. And y'all, when you got a fraction like this, you got to divide both of these on top by that h. So if you take the 2hx and divide out the h's, all that's left is the 2x. But y'all, what I'm worried about, what if I had an h squared? What happens when I divide an h squared by an h? That means, oh, I'm hearing you. So what'll be left?
Yeah, just H.
Just the h. Good job. Because you had two h's on top, one cancels, leaving me with one h. None of these are like terms now, so that would be our final answer. So that last step, all you're doing is dividing h's out of everybody and being done with it. Now, y'all, save this right here because we will use this on number 4. I just want to give y'all just a second to write that, and then we'll spin it over, okay? All right, y'all, so these last two are a little tedious, I would say. But y'all's 5 problems are going to be really, really similar to what I'm doing. They're just going to change the numbers up a little bit, okay? Y'all, here comes the fun one. One of the longer ones, I would think. I got an f of x equals negative 5x squared plus 9x plus 2. So we first going to find, and we're still plugging it into this. So we first need to find f of x plus h. But y'all watch out, there's 2 x's in this equation. So I need to replace both those x's with the x plus h. Square that one, plus 9 times x plus h, and then plus my 2. Now, I'm going to bring down that negative 5. We know what x plus h squared is because we did that on problem 3. X plus h squared is a x squared plus 2hx plus h squared. Then we bring down our plus 9 times x plus h, and then we bring down our plus 2. So we got negative 5 times our x plus h squared plus 9 times the x plus h plus 2. Now we're going to get rid of the parentheses. We're going to distribute negative 5 in the first parentheses. So negative 5 times x squared is a negative 5x squared. Negative 5 times 2hx is a negative 10hx. Negative 5 times h squared is a negative 5h squared. So I distributed that -5. Now I'm going to distribute the 9 in the second parentheses. 9 times x is a positive 9x. 9 times h is a positive 9h. And y'all, at the very end, we bring down R2. Now, let me tell you what's sort of sad on this problem. There are no like terms in here. None of this adds together. So y'all, this whole thing is my f of x plus h. So let's plug it into our formula. F of x plus h is all of this, -5x squared minus 10hx minus 5h squared plus 9x plus 9h plus 2. That's going to be minus my f of x. Well, they gave us that up here. That's -5x squared plus 9x plus 2. All of that over RH. So y'all, this is when you start loving this algebra, right? You got all kinds of terms up here. But remember, all three of these are going to cancel with their counterparts. -5x squared, a negative times a negative makes that a positive 5x squared. They cancel. Next, I got this 9x minus this 9x. They cancel. And y'all, what's left? I got this 2. This 2 minus this 2 cancels. Make sure at this point that everything that's an f of x cancels over here. So that's going to shorten it down a little bit. All that's left is the -10hx minus the 5h squared plus the 9h all divided by h. So y'all, my question of the day would be, what would my final answer be? Any guesses?
10x minus 5h plus 9.
Oh, you're so good, but I don't, did you say the -10?
No, but it's supposed to be.
So -10x. So good job, because you simplified these perfect. Because 1h canceled in the middle, leaving me a -5h. And then that 1h canceled on 9h, leaving me just a 9. So if it has just 1h, they're going to cancel. If they had 2, take 1 away. And y'all, there's no like terms. So that is our final answer. And y'all notice the whole trick to this problem was this f of x plus h stuff right here. Woo, that's a dandy there, but that's a trick. Anywhere there's an x, I put that x plus h and start trying to simplify these, okay? Now, y'all, look at this last one. Let me let y'all write that for a second, and then we'll do number 5. Now, number 5 is a little bitty one. You would think. So let me ask y'all, any of y'all going to be taking business calculus or anything like that?
I don't think so.
No, sir.
All righty. So, but if you did, this would be something you'd get to play with.
You say play like it's fun.
Well, it's sort of fun when you get the right answer, though, ain't it?
I mean, it feels good, I guess, but
Yeah, y'all can't say when you get them right answers, it's like, oh my God, I got
what about the 5 million times we have to redo it?
Well, that might be probably doing someone else's job and I couldn't do it. And I'd be like, damn, I can't do this. But I could keep trying. Maybe I could eventually, right?
Yeah, I'm trying if you will, but
But y'all look at this one. This one is just f of x equals a 4 x cubed. So here's our formula again, f of x plus h minus f of x all over our h. So this don't look too bad. There's just one thing here, but let's see what happens when we find f of x plus h. That's going to be 4 times x plus h cubed. So I'm going to go over to the side. Now remember, whatever I get for my x plus h cubed will be the same thing you are going to use for your x plus h cubed. I'm pretty sure the only thing they're going to change on this problem is the 4. Y'all might end up with a 3, 5, negative something, who knows? But y'all, x plus h cubed is the x plus h times the x plus h times x plus h. So we know what 2 of these equal. So I'm going to bring down the first x plus h, because we know that this x plus h times this x plus h, we know that that gave us the x squared plus 2hx plus h squared. So I'm just using what we got a while ago for 2 of these. But y'all, guess what? I still got one left. So now what I got to do is distribute this x times all 3 of these, then distribute that h times all 3 of these. Now, when I multiply variables, I'm still going to keep mine in alphabetical order. So y'all, what do you get if you multiply x times an x squared? That's going to be an x to the 3rd. Remember, you're just adding exponents, and if they don't have one there, treat it like a 1. So 1 plus 2 gave me 3. Now, x times 2hx will be a 2hx squared. So since I'm adding the x through here, that's all that's changing are the x's on this. And then this x times h squared gives me a h squared x. So I added an x to everybody when I distributed an x. That went from 2 x's to 3. This had a 2h, 1x. It went to 2 x's. This had an h squared. It became an h squared x. Now we're going to distribute the h. H times x squared is a h x squared. So all we're doing now is adding h's to all of these. H times 2hx is a 2h squared x. And then y'all, finally, that h times that h squared is a h to the 3rd. Now you do have like terms in this stuff. So I'm going to bring down my x to the 3rd. Notice here's 2hx squareds. Over here I have 1hx squared. So the 2hx squareds plus the 1hx squared gives us 3hx squareds. Here I have an h squared x. Here I have 2h squared x's. So this h squared x plus 2h squared x's give us 3h squared x's. And then y'all, at the very end is our plus h to the 3rd. Anytime y'all get an x plus h to the 3rd, that is what we're going to replace it with. So y'all, that gives me 4 times all of this, x to the 3rd plus 3hx squareds plus 3h squared x's plus h to the 3rd. So I plugged all that in for the x plus h to the third. Now to get rid of these parentheses, we're going to distribute the 4 to all 4 parts of this. So you'll get a 4x to the third plus 4 times 3 gives me 12h x squared. 4 times 3 gives me 12h squared x's. And then finally 4 times the h3 gives me 4h to the third. I have no like terms in here. Although these hx's look the same, they got different exponents. Like this h has a 1, this one has a 2. So that's making them not like terms. So this cannot simplify any further. So we now going to plug everything into our formula. So y'all, although that x3, this thing looked a lot smaller, look how much foiling you have to do over here. All righty, so bring this down as the f of x plus h, 4x to the third, plus 12hx squared, plus 12h squared x, plus 4h to the third, minus my f of x, which was 4x to the third, all divided by RH. And y'all, if you notice, only one thing's canceling this time. 4x third cancels with the negative 4x to the third. So we got 3 things left. We got 12hx squared. Plus I got 12h squared x. Plus I got 4h to the third. All divided by h. Any guesses on my final answer?
Is it 12x squared plus 12 squared x, or?
Well, you're so close, but just take this h squared and divide it by 1h. So
Okay.
if you had 2 h's and you cancel 1, that's going to leave you 1h and then your x.
Plus 4 to the third.
Well, you're so close, but now remember the 3 don't go with the 4. So now this is 3 h's on top and you're going to cancel 1.
Oh, okay.
So what's that going to leave me? H squared. So see, 1h with 1h cancels. 2 h's with 1h. 2 minus 1 left me 1h. If you got 3 h's, 3 minus 1 left me 2. So basically, you take 1h out of everybody on top, and you got your final answer. So this looked like the smallest of all my problems, but y'all, that exponent 3, that made this problem a lot trickier, okay?
So we only have 2 of these problems on the homework, right?
You got the same 5 I got.
Okay.
So, yeah, if you follow these notes and just go through them, you're going to have the same. Instead of a 4, they might give you a 5 here. So you'll be distributing a 5 through instead of a 4. But your x plus h cubed is going to always be what I got here. And on that other page when I was doing it, the x plus h squared will always equal what we got on those. So save these for your sides, and you'll know what to put in when you got these cubes and stuff, okay? All righty, so y'all, those are what you got to look forward to if you're taking some business math, okay? All righty, so I'm just gonna, if you're good on supporting stuff, I'll let y'all go and I will see y'all. So I'm gonna stop my recording. So let me stop my recording real quick.